So we're all here whenever.
So we are all here. So if you are ready, we could start with the PhD presentation. So when you want, you can upload your presentation and start with your intervention.
I'll share my screen. Okay, great. I might take a few seconds to change the screens and such.
Sure.
Yeah. Maybe we should. Okay, let me share there. Okay. Yeah, now I can see. No, that's not what I need. Hold on, sorry. Sorry. Okay. So, yeah, that's better. There. So everyone here can see my screen, and you can also see my screen, right?
Yeah.
Okay. Well, thanks everyone for being here. I'm gonna give a talk about my PhD that is entitled Reading Acquisition from Digital Screening to Neurocognitive Bases in a Transparent Orthography. This was carried out in 2 institutions at Universidad de la República in Uruguay, where I work, and at the Basque Center on Cognition, Brain and Language. And the doctoral program is the doctoral program from Universidad de País, Vasco. So my mentors were Juan, Valle, Lisboa at Universidad de la República and Manuel Carreiras at the Visbiel and Universidad del País Vasco. So the title of the thesis is Reading Acquisition from Digital Screening to Neurocognitive Bases in a Transparent Orthography. I'm gonna, okay, yeah. So the outline of the talk is I'm gonna go first into the background. I'm gonna go through how reading acquisition develops, phonological representations, and reading experience and preliteracy skills. Then I'm gonna quickly go into the general methods for all the studies. And then I'm gonna go into the main results of each of the 4 studies, and finally a general discussion. So to start with the background, one of the main topics that we were interested in was on reading acquisition and how it develops. The first stages during reading acquisition in children is what we call the decoding phase. So when children are learning how to decode, they are learning how to map each letter or grapheme into its corresponding sound or phoneme, and then they blend them together to sound out words. Now, there's a set of preliteracy skills. This is cognitive skills that develop before children start learning to read that are very strong predictors of their future reading acquisition. These preliteracy skills entail phonological awareness. This is our ability to identify and manipulate the sound units of language. It's measured in tasks such as segmenting a word into its corresponding phonemes, or segmenting it into its corresponding syllables, or blending syllables or phonemes together. It can refer to the syllabic level or the phonemic level, and it's one of the core constructs in the reading acquisition process. A second skill that is developed before children learn to read, and it's a very strong predictor of their future reading skills, is letter knowledge. Self-explanatory. So children need to know letters names and letter sounds in order to decode words. And a third skill that is not so much a skill but a task is rapid automatized naming. So in rapid automatized naming, children have to name as accurately and as fast as possible a set of either objects or colors or numbers in a grid that are presented in a grid, and they have to name them from left to right and from top to bottom. So this first, it emulates some of the ocular and attentional movements that they're gonna later need for reading text. And also it taps into some underlying cognitive skills such as lexical access and lexical retrieval. This is another very strong predictor of future reading skills. And finally, verbal short-term memory, which has received kind of a mixed treatment in the literature. So sometimes it's thought of another pre-literacy skill itself, and sometimes it's thought as a general cognitive skill. In either case, it is also a very strong predictor of future reading abilities. I'm going to use the term phonological processing to refer to both phonological awareness and verbal short-term memory together because they both involve phonological skills. And so we know a lot about these pre-literacy skills and their role in future reading acquisition, but most of the evidence comes from studies that are carried out with English speakers. So English is kind of an atypical orthography. We can categorize orthographies in a continuum from transparent to opaque. So English is in the opaque end of the continuum. This means that each letter can have many different sounds. So the mapping between graphemes and phonemes, or approximately letters and their sounds, is very inconsistent and is very dependent on the context. On the other extreme, we have languages with transparent orthographies. For example, Spanish is in that extreme, together with Finnish and Greek and Italian, in which the mapping between graphemes and phonemes is very, very consistent. So in Spanish, for example, the letter A always has the sound A. It doesn't matter which word. However, in English, the letter A can sound as in table or as in cat, which are very different sounds. So of course, this consistency or inconsistency between the mappings of graphemes and phonemes modulates how the reading acquisition process develops. And we know that in more transparent orthographies, children attain high accuracy in their decoding skills early on, while for opaque orthographies, the process is a bit slower. So children take about 2 years to have high accuracy in their decoding skills. And moreover, when we look at reading difficulties, it is generally in transparent orthographies, they are generally more evident in processes with reading speed rather than with reading accuracy, which is something that children attain very early on. So we wondered, and it is kind of controversial in the literature, how these pre-literacy skills behave and what is the relative weight in a transparent orthography, such as Spanish, which is the language in which we're going to carry out this study, rather than what has been described for. Sorry, someone's mic. Okay. I don't know what that was, but I'll keep going. There. Now, if we're interested in how these pre-literacy skills develop, and one of the core pre-literacy skills is phonological awareness, then it's interesting to ask why there are differences in phonological awareness skills across children. And this has to do with their phonological development. So we went one step further in this causal sequence of skills, and we wanted to look at how these phonological skills develop. Now, in order to understand this, it is very important to think how speech works. And speech, even though we feel and we perceive it as a discrete signal, it is not. Speech is a continuous signal when there are no clear boundaries on when a word ends and another word begins, or when a syllable ends and another syllable begins, and even more so, there are no clear boundaries on how a phoneme ends and the next phoneme begins. So the brain has to solve this issue of turning this continuum stream of information into discrete chunks. And one of the mechanisms that has been proposed for chunking or segmenting the speech signal is by brain rhythms. So on one hand, in the speech signal, we see that there are different rhythms. So the slower rhythms in the speech signal refer to what we feel as listen as prosody. So that is kind of the rhythm in speech. And this occurs at about 2 Hertz, what we term the delta rate. And this in turn defines a temporal window within syllables and phonemes fall. So syllables also occur in a rhythmic manner in the speech signal, and this rhythm is a bit faster than the one from prosody. It's about 4 hertz approximately. And within this temporal window defined by syllables, phonemes fall. So phonemes occur also in a rhythmic manner at about 35 hertz in the speech signal. So there's this hierarchy of linguistic information present in the speech signal, which needs to be segmented and discretized. In the brain, we know that there's also endogenous rhythms of the electrical activity of the brain, and especially in the auditory cortex, there has been described at least 3 endogenous brain rhythms. So delta, which is at about between 1 and 3 hertz, this is like oscillatory activity, electrical activity of the brain, and this corresponds in frequency to the rate at which, can someone mute? Someone is, okay. Sorry. The delta rate in brain rhythms corresponds approximately to the rate at which prosodic information occurs, and the theta rate in the brain rhythms occurs at approximately corresponding to syllabic information in speech, and the gamma rate corresponds approximately to phonemic information in speech. Now, crucially, it has been shown that first, there is brain-brain synchronization. So these 3 frequencies in the auditory cortex are hierarchically organized and are nested within each other. So the phase of slower rhythms, such as delta and theta, modulates the amplitude of faster rhythms, such as gamma, and this works as a binding mechanism of these different temporal windows. And on top of that, it has been shown that the electrical activity of the brain, so these brain rhythms, synchronize to rhythms in speech, especially at slower rates. So there's this phase locking mechanism in which delta and theta rates in the auditory cortex modulate their phase so that it can synchronize to slower rhythms in speech. And this mechanism of coupling or synchronization or entrainment between these 2 signals works as a mechanism for speech segmentation. If this is so, then the quality of the synchronization between brain and speech should index the quality of phonological representation, so of this abstract phonological linguistic information, such as having a representation of discrete phonemes or discrete syllables or even words. And then if we look at the precision of brain and speech synchronization, we should be able to explain phonological awareness, which is the conscious access of phonological representations. And then we should be able to explain by brain speech synchronization future reading acquisition. This is what is known as the temporal sampling framework, presented by Usha Goswami in 2011 approximately. And so I'm going to use the term rhythmic sensitivity to refer to the quality of this synchronization between brain and speech or brain and auditory input. This rhythmic sensitivity can be measured through both tapping to a beat. So for example, children listen to a beat in time and they have to tap or clap at the same time, or directly through the electrical brain activity with electroencephalography, which is one of the things that we're going to do. Now, a third issue is the reciprocal effects between reading experience and pre-literacy skills. So as I've told you before, pre-literacy skills are very strong predictors of future reading experience, or future reading acquisition and skills, but we also know that reading experience itself modulates and enhances and promotes the development of pre-literacy skills, and this has been shown for phonological awareness, but also for rapid automatized naming and for verbal short-term memory. If this is so, and if we want to understand the causal relations between pre-literacy skills and reading experience, we need to make sure that we don't have this reciprocal effect, that we avoid this interactive process between reading experience and pre-literacy skills. And this is one of the points that Falk-Hütig and colleagues made in 2018, saying that a substantial number of dyslexia research findings are a proxy for a lack of adequate reading experience. So if you are testing children who already have some reading experience, it is hard to disentangle whether the difference that we observed across children are a cause of the reading difficulties or a consequence of the fact that children that have reading difficulties have less experience with reading and have a different reading experience in terms of both quantity and quality. And what they suggest that we could use as an approach to avoid this confound is to carry out large-scale longitudinal studies. So with all these elements in mind, we thought about these general research questions. The first one is, how does orthographic consistency modulate the role of preliteracy skills in future reading acquisition? The second one, can rhythmic sensitivity at the behavioral level explain differences in phonological processing and in future reading acquisition? The third one, can rhythmic sensitivity at the brain level explain differences in future reading acquisition? And an extra one that is a more applied or question, that is, if these preliteracy skills predict future reading, can we, by measuring preliteracy skills, build a digital screener to identify children at risk of reading difficulties? So we think of these questions in a translational framework, bridging neuroscience, cognitive and educational research. And so the whole thesis spans digital screening in the school context to neural synchronization in the lab. So with these questions in mind, we thought about 4 studies. We designed 4 studies. In study 1, a universal screener for reading difficulties aims at developing a digital screener to identify kindergarten children at risk of developing reading difficulties. Study 2 studies the cognitive substrates of reading acquisition and aims at unraveling the role that preliteracy skills play in reading acquisition when examining it in a transparent orthography. Study 3, dissecting the contribution of rhythmic sensitivity, addresses how rhythmic sensitivity relates to phonological processing and reading acquisition at the cognitive level. And study 4, neural synchronization and reading acquisition, addresses the rhythm-reading relation at the neural level. So I'm going to go into the design and methods for all of the studies now, and then I'll go into the results. So in order to address these questions, we carried out a longitudinal study where we followed the same sample of children across time. We started in kindergarten, in the last year of kindergarten, which I'm terming K5. Children were approximately on average 5.8 years old, and the sample was composed of 616 children. Then we assessed the same children at the end of first grade, so that is G1. The sample here was composed of 397 children. And then we followed the same children until the end of of second grade, and this was about 250 children. These were all Spanish speakers. They were attending kindergarten in 26 public schools in Montevideo in Uruguay. These were middle and high socioeconomic status, but public. And in order to assess all the skills that I described before in such a large sample, we designed sort of video game that we called Lexiland. So we took advantage of the fact that in Uruguay, the One Laptop Per Child program developed at MIT has been implemented nationwide, so children have access to digital devices at their schools. And so Lexiland is a video game with a main character that is called Alex, and Alex walks into a town and he has to go inside different houses, and in each house he has to solve a game or task, which assesses one of the cognitive skills that I mentioned before. For example, this shows a phonological awareness task of segmentation. So children listen to a word, in this case would be beso, which is kiss, and they have to say how many syllables or how many phonemes there are in that word. And since we were using digital devices, all of the instructions were pre-recorded. So the whole battery was self-administered, and we did it in groups. As you can see here, this is 4 children. They are sitting like in the hallway of the school, which was very often the context in which we assess children, because there wasn't always a room available for us to work in. And what we measured was letter knowledge, 2 tasks, names and sounds, rapid automatized naming, 4 tasks, phonological awareness, also 4 tasks, verbal short-term memory, and also decoding, fluency, and comprehension. These were, of course, except for comprehension, not self-administered because someone had to listen to children's responses and write it down. And then general cognitive and demographic skills such as IQ, nonverbal short-term memory, and vocabulary. And we also had their age and their socioeconomic status from the school database. So all of the results that I'm gonna describe next come from this digital assessment carried out at the schools. So for the first study, one of our motivations was the Dyslexia Paradox, so stated by Osornov, Valle, and Gaab in 2016. So the idea is that dyslexia is generally diagnosed after the most effective time for intervention has passed. What is current practice today in Uruguay, I think in Spain is the same, and in the States it's probably similar, is that children are taught how to read when they enter first grade, and if they are performing a little under their peers or not according to what you would expect, we will give them more time because each child is different, that's the reasoning. So we'll give them more time and wait until second grade. In second grade, if they are still not performing according to what we expect, we also give them a bit more time until third grade. If in third grade they are underperforming, then they are generally referred to a specialist, and in many cases, the diagnosis of dyslexia is done. However, by now, children have been for 3 years struggling with reading. They have acquired less reading experience, and they also have generally developed a negative attitude towards reading. However, as I said before, there are skills that develop before children learn to read that can give us an idea of how the reading acquisition process is going to develop. So we could do something to measure them early on and then intervene early on and avoid all these cascading effects. Even more so, we know that the earlier we intervene, the most effective the intervention is going to be. So with this in mind, we used Lexiland to build a classifier to identify children at risk of reading difficulties. Our main analysis was a logistic regression of kindergarten preliteracy skills to predict first grade reader status in 2 groups, typical and poor readers. What I'm showing you here is the distribution of the reading scores at the end of first grade. The reading scores here is a composite of decoding, fluency, and comprehension. And what you should note from this is that the distribution is clearly bimodal. So there is most of the children are reading according to what we expect, but there's a large size of them, a large number of children that are not reading according to what we expect. So we split this distribution into poor readers, those that were performing below 1.3 standard deviations of the mean, and typical readers. So this was 64 children, so about 16% of the sample for poor readers and the rest for typical readers. If we look at their actual reading scores, you can see the typical readers here in green and the poor readers here in blue. And what you can appreciate is that poor readers actually have no reading skills at the end of first grade. So for decoding, their accuracy scores is about 0. For fluency, they read less than a word per minute. For comprehension, their accuracy scores is about 0. And in the composite score, on average, they are below 1.5 standard deviations of the mean. So next, we wonder whether by all of the preliteracy and cognitive skills that we measured in K5, how good are we, how precise are we in trying to classify children into these 2 groups, so to build a model for this. So what I'm showing you here is an ROC curve, so receiving operating characteristics. This comes from the signal detection theory. And in the y-axis, you see the sensitivity score. So sensitivity means out of all of the children that will develop reading difficulties, how many we can correctly identify. And in the x-axis, you can see 1 minus specificity. So specificity means that out of all of the children that will not develop reading difficulties, how many can we correctly identify? And each line in here represents a run of the classification model. And you can see here 1,000 runs. What is marked with the lines is the average classification accuracy for these 1,000 runs. These 1,000 runs are cross-validation runs, so we took all of the sample and we split it in 80% to train the classifier and 20% to test the classifier. So this is how well the model performs with the test set in 1,000 different runs. And what we get is that on average, in this cross-validation process, we can correctly identify 9 out of 10 children who will develop reading difficulties. This is 90% sensitivity. And for that sensitivity, we can correctly identify almost all 8, so 7.6 out of 10 children who will not develop reading difficulties. These are equivalent to those reported in the literature, but those reported in the literature very often are carried, the assessment is carried out individually by many times a trained specialist. And this was done in the school settings in groups, so we're pretty satisfied with this. So what we can conclude is that universal digital screening for reading difficulties in the school context is both feasible and cost effective, and that it can attain high classification accuracy even when doing it in a brief, self-administered and in groups. I didn't mention this, but the results that I've shown you before can be obtained by measuring only 4 tasks out of all of the ones that we measured. So the next question was more of a theoretical one, and our objective was to assess the unique contribution of kindergarten phonological awareness to first grade reading acquisition in order to understand the relative role of preliteracy skills in future reading acquisition in a transparent orthography such as Spanish. Our main analysis was linear mixed effect models of kindergarten preliteracy, cognitive and demographic measures to predict first grade decoding and fluency scores. Now, while this study uses the same sample as the study before and the one that I described in the methods, there are a few methodological differences that are important. For example, first, in this analysis, we excluded all children that had any reading skills during kindergarten in order to avoid these reciprocal effects between reading experience and preliteracy skills. And we also included in this analysis the school as a covariate, because of course the school can explain or should explain a lot of their reading skills, and this is important if we are to understand more of their cognitive or individual variables that explain future reading skills beyond those cultural or environmental. So the main result for this study, which I'm showing here, this plot shows the coefficient of the regression coefficient for each of the variables of interest for explaining decoding at the end of first grade or fluency at the end of first grade, and the colored bars represent those that are significant. And what we see is that for decoding, both letter knowledge and rapid automatized naming can explain future decoding skills together with verbal and non-verbal short-term memory and socioeconomic status. And for fluency, both letter knowledge and rapid automatized naming, as well as socioeconomic status and gender, can explain future fluency skills. What is surprising here is that we don't find that phonological awareness contribute unique variance above and beyond these other preliteracy skills, which is a result that has been previously shown in the literature. To conclude from these studies, we think that we found that in a transparent orthography, letter knowledge, RAN, short-term memory, and socioeconomic status are the main significant predictors of future reading acquisition, and that phonological awareness does not contribute unique variance to future reading acquisition. We don't think this means that phonological awareness does not matter, but I'll go into that at the end when we go into the general discussion. Now, in the third and fourth studies, we moved into looking at rhythmic sensitivity. So in study 3, we were trying to dissect the contribution of rhythmic sensitivity to future reading skills. So our objective was to test the relation between rhythmic sensitivity, phonological processing, and reading acquisition as proposed by the temporal sampling framework. And their main analysis was hierarchical regression of rhythmic sensitivity and phonological processing to predict reading efficiency. So to measure rhythmic sensitivity behavioral we designed a task that was also embedded in the Lexiland environment. I hope you can see this video okay through Zoom, but this is a child that is performing the tapping to a beat task in the school setting. So he has to tap at the same time as he's listening to a beat. And you can see that he's also tapping with his foot, even though he doesn't need to tap with his foot, but he's really into the task. And that was generally what we found, that children really enjoyed this task, probably because there was a bomb involved and they really liked that. And the stimuli were at 3 different frequencies, 1 hertz, 2 hertz, and 4 hertz. And what we found is that what I'm showing here is the regression coefficient for the rhythmic sensitivity in trying to predict efficiency, which is a ratio for decoding accuracy and decoding speed. And what we can see first is that rhythmic sensitivity predicts during kindergarten, predicts efficiency at the end of 1st grade, so decoding at the end of 1st grade, even above and beyond age and IQ and gender and nonverbal short-term memory. Now, in the next step, what we did is we included the phonological processing skills that should be the mediators between this rhythmic sensitivity and reading or decoding scores into the same model. And what we found is that when we include this phonological processing, so verbal short-term memory and phonological awareness at the syllable and at the phoneme level, the coefficient for rhythmic sensitivity is greatly reduced. So we take this as the fact that phonological processing skills are mediating this rhythmic sensitivity reading association, but also we see that the rhythmic sensitivity still contributes unique variance to future decoding. So this means that there must be an association between rhythmic sensitivity and future decoding that is not explained by phonological processing skills. So what we conclude from this study is that rhythmic sensitivity in kindergarten predicts future reading acquisition, even above and beyond some general cognitive and demographic variables, and that this reading link is both mediated by phonological processing and independent from it. I'll go into that again in the discussion. So the last study, we wanted to test the relation between neural synchronization, so a neural measure of rhythmic sensitivity, to non-speech rhythm at 2 frequencies of interest, delta and theta, and future reading acquisition. Our main analysis was linear mixed effect models to predict neural synchronization from reader status, so in 2 groups, poor and readers, poor and typical readers. Sorry, there's a typo there. So for this, we measured the electrical brain activity of children with electroencephalography. Of course, this was not the whole sample. These were 35 children when they were in kindergarten, and we tried to explain their future reading status 1 year later. The task was an auditory task. They were listening to amplitude modulated white noise. So this is a rhythmic stimuli that has no linguistic information. So, and this was done in 4 conditions: at delta rate, which is about 2 hertz, at theta rate at 4 hertz, at 8 hertz, and unmodulated. So these conditions, the delta and theta, or 2 and 4 hertz, were chosen because they are speech relevant. As I said before, they correspond approximately to prosodic and syllabic information in speech, respectively. The 8 hertz was chosen as a control condition since it's not speech relevant. And the unmodulated is a second control condition. If in case you're wondering what it sounds like, so amplitude modulated noise, when it's not modulated, so in the unmodulated condition, it sounds like shh. And when it's modulated, 2 hertz, for example, it sounds like shh. So children were listening to this stimuli through headphones, and they just were watching a silent cartoon. They had no task except they had to answer some questions about the cartoon later on. And there were 35 children. I think I said that before. Now, what I'm showing you first is their neural synchronization, irrespective of reading yet. So during kindergarten, what you see from this plot is on the top, the large panels show the stimulus frequency. So this is when they were listening to 2 hertz condition. This is when they were listening to the 4 hertz condition. And this is when they were listening to the 8 hertz condition. What you see in the bottom is the brain response in power. Actually, it's signal to noise ratio at 2 Hertz, so the power of the brain signal at 2 Hertz, the power of the brain signal at 4 Hertz, and the power of the brain signal at 8 Hertz, in all of them when they were listening to a 2 Hertz, and so on and so forth. So what is evident from this is, first, when they are listening to a 2 Hertz stimuli, the largest brain response is at 2 Hertz. So 0 here represents the y-axis represents the difference between the brain response and the power of the signal at the frequency of interest, in this case 2 Hertz, minus the power of the signal when they were listening to the unmodulated condition. So what you see here is the specialized brain response, specific brain response to the fact that the stimuli is modulated in time. And what you see from here is that the largest response occurs at the same frequency at which they are listening. So when they are listening to 2 Hertz, the largest response is also at 2 Hertz. There's also a significant response at 4 Hertz, and there is no significant response at 8. And the same pattern repeats when they are listening to a 4 Hertz condition. The largest brain response is also at 4 Hertz, although there's also a significant brain response at 2 Hertz, and there is no significant brain response at 8 Hertz. And when they are listening to the 8 Hertz condition, which is not speech relevant, there is no significant brain response. So the brain response not different from hearing a signal that is modulated at 8 Hertz than to a signal that is not modulated. Next, we're gonna relate how the precision or quality or magnitude actually of this brain response relates to future reading skills 1 year later. In order to simplify, we're gonna keep only the largest response. So we're gonna use the 2 Hertz brain response for the 2 Hertz stimuli and the 4 Hertz brain response for the 4 Hertz stimuli. I'm gonna use the term delta to refer to the 2 Hertz and theta to refer to the 4 Hertz. And as with the larger sample, we split children into 2 groups, into poor readers and typical readers. There were 28 typical readers in the sample and 7 poor readers in the sample, so it's kind of a not very large sample, really. And what we find first for delta is that first, poor readers show on average no neural synchronization at delta rate, so their brain doesn't respond differently from a modulated than to an unmodulated signal on average. And for typical readers, we do find neural synchronization. And moreover, we find significant differences between the brain response of the poor readers and the typical readers. If we look at the topography of this effect, we find, so sorry, this is very small, but we tested 4 electrodes. There's an error in the written thesis here. It says 1 electrode, there's something missing. So we tested the 4 electrodes that on the whole group showed significant neural synchronization. So there's 1 anterior electrode and 3 posterior electrodes. And what we find is that the difference between poor readers and typical readers is only observed at this anterior left electrode. Now for theta rate, what we find is that both poor readers and typical readers show on average neural synchronization, so a specific brain response to that modulation rate, and also that there are no significant differences between the 2 groups. So from this, we conclude that pre-reading children show cerebral specialization for auditory processing at speech relevant rates, that neural synchronization at delta rate predicts reading status 1 year later, and that neural synchronization at theta rate does not predict reading status 1 year later. So next I'm gonna go into the discussion of each study except for the first one, which is kind of applied. So for study 2, we have shown that the contribution of preliteracy skills to reading acquisition in a transparent orthography shows a distinct trajectory, that letter knowledge, rapid automatized naming, verbal short-term memory, and socioeconomic status are the main contributors to reading acquisition. And we found also that phonological awareness does not contribute to unique variance. We think that this can be explained by a tight association between letter knowledge and phonological awareness, and tighter in Spanish than in English. So in Spanish, if you know letter sounds, then you kind of have all of the information that you need to decode. You just need to turn each letter into its corresponding sound, which is almost always the same. And then you need to blend them together, and then you are decoding. In English, this information is not enough because the letter sounds or phonemes are very dependent on the context and very variable. So this is not enough in order to sound out words. That's also why we think they can explain the strong role for verbal short-term memory. So by having strong letter knowledge and strong verbal short-term memory, you should be able to decode. And more so, we think that the lack of the phonological awareness contribution can be explained by the fact that we excluded children with any reading experience during kindergarten. So these children might have shown enough variability in the phonological awareness skill in order that could explain future decoding. But if we include these children in the sample, we're not sure whether this phonological awareness variation comes from like pre-reading or is a consequence of the reading experience. So we think this can also explain the lack of the unique contribution of phonological awareness. So with all this in mind, we think that a universal model of reading acquisition should be revisited and that we should take into account the characteristic of the orthography in order to think of these models. Now for the third study, we showed that rhythmic sensitivity explains future reading acquisition, both through phonological processing as predicted by the temporal sampling framework, but also beyond phonological processing. We think this could be explained by the role that lexical stress assignment plays, in particular for polysyllabic words. So in Spanish, since the decoding process is easier, children encounter polysyllabic words very early on during reading acquisition, which is not so frequent for English. And in order to correctly decode polysyllabic words, you need to assign stress correctly. And that is a temporal processing skill in a way that could be measured, that our rhythmic sensitivity measure could be tapping into, and that is not explained by our phonological processing measures, which were phonological awareness and verbal short-term memory. So rhythmic sensitivity, as measured through these tapping to a beat tasks, underlies reading acquisition through several cognitive or linguistic pathways that we would need to further explore. And for the last study, we have shown that neural synchronization to auditory rhythms explains future reader status for delta rate at anterior sites. And so, as you know, the EEG technique has a very low spatial resolution. So it's really hard to conclude things about where things occur. But we think this anterior effect it's more compatible with an interpretation of top-down effects from frontal sources. So for auditory process, it has been reported that synchronization at anterior sites, so from frontal sources, modulates neural synchronization at the auditory cortex, specifically from the left inferior frontal gyrus to the right auditory cortex. And these have been linked to different cognitive functions, such as chunking in memory or syntactic processing. So we don't know what it is, but we think it's hard to interpret our results as coming from auditory cortex itself. So this provides support for the role of neural synchronization in speech segmentation and also in future reading acquisition. So the main contributions of this thesis are that by employing a large sample in a longitudinal design, we have been able to control for relevant confound variables in our research questions and avoid reciprocal effects of reading experience. By studying children from a transparent orthography, we have provided novel and infrequent evidence to the discussion on the universality of reading acquisition. By testing the neural correlates of auditory processing before reading acquisition, we have shown for the first time that pre-reading auditory processing at speech-relevant rates predicts future reading status. And by developing a digital screener and testing it in an ecological context, we have shown that it is possible to obtain high classification accuracy of future reading status, which is a scalable and a cost-effective approach and could be implemented in the whole school system. So this is part of everyone who worked in this from Universidad de la República and in Facultad de Psicología, from the Basque Center on Cognition and Brain and Language, and also the funding agency, and especially all the schools and teachers and families involved, which we are very grateful for. That's it.
should I talk? Can I talk? Can I start?
Hold
or
on,
Manolo?
sorry. There.
Yeah. I don't know, because technically I'm the president, or?
You are the president.
So
but I think you should be the last one.
Yeah, I guess that, well, you should be the first one.
I should be the first one.
Guess. Yeah, and then Nadine, and then myself.
Okay. Then
yeah,
I should start.
Yeah, so thank you, Camila, for your presentation. So now we're going to ask a few questions on your very nice presentation, I have to say, to anticipate. So Joana Acha is going to start. Yep.
So thank you very much, Camila, for this presentation just in time, and a very good presentation just in line with the quality of your work, I have to say. Well, first of all, I would like to thank the directors for offering the possibility to be here today and being part of the committee, and to have the opportunity to read this thesis, because I really have enjoyed reading it. I see two great virtues in your work, Camila. The first one is that it is written in a very clear and understandable way, and approaching the broad literature in a very deep and pertinent way. It's not always easy to explain things in a simple way when the object of analysis is complex. And in the case of reading dyslexia in this field, there is a vast literature, there are many works, too much research, and sometimes very different views, sometimes inconclusive evidence. So generally, it requires a good capacity for understanding, integrating, and deeply analyzing the material. And I think you did a very good job. In your case, it has been achieved. And the second one is that you present 4 studies that meet the high demands of developmental psychology nowadays. That is very big, in your case, huge sample, longitudinal study, several tasks to tap into one construct or latent variable. So there are valuable points that need to be highlighted. So you have presented a very good work, and I can only congratulate you for this job. Apart from this, I have some questions and some suggestions. I will start with the questions. I will pose just 4, because then Nadine and Manolo will have some more. The first one, you can take notes if you want, because there are 4. Or if you remember, if you think you will remember, there is no need. The first one is related to the suggested reciprocal interaction between reading and phonology in your work. And in line with this, you mentioned the possibility of reading environment having a role in your predictive analysis, in your results. My question is whether did you, in line with the work of Huetin et al. That you mentioned, whether you checked any reading habits at home or scaffolding habits, parent scaffolding reading habits at home, so that you can find a relation between this predictive relation you find between socioeconomical status and reading, because SES explains reader status in your study 1, and also explains the phonological awareness reading relation in your study 2. So I wonder whether there's something to do with this, even when you, in some cases, select the bright readers that did not have a reading experience. Did you measure whether there was some reading experience at home or reading scaffolding at home due to this interaction you talk about? So this is the first question. The second one is related to the fact of using phonological awareness tags that avoid verbal responses. So you mentioned the reason in your presentation. So the reason was that you didn't want them to write down. And this is a good answer, but maybe in the PhD, in the written work, the reader should require a better explanation, a better theoretical explanation of that. What was the theoretical rationale of this choice? So in the literature, Jane Oakhill and some colleagues have reported a phonological awareness working memory relation with a typical task that require both receptive and production component of the phonological awareness task. So they have to talk, they have to produce sounds. In your case, it is interesting that you find the same relation, but only testing the receptive component, so eliminating the productive component of the task. And this is interesting in itself. It's an interesting result, but it should require a better theoretical explanation about why you choose doing this and the possible and the potential implication of the finding. The third question is related to the categorization approach you adopt in your study. So you decide to select poor readers and good readers based on the standard deviation. Now, my question is, why did you choose this approach? And what are the consequences of this? Because while I was reading, I was thinking, what about the children that stay in the 17th percentile or 18th percentile or even 25th percentile, those who are in the middle of the distribution and that do not belong, who are not very bad readers or very good readers? Probably the predictors will be the same, but will the weight of the predictors change? That's an interesting question that has not been responded. And I would like to know whether you thought of choosing this possibility at some time, and why did you decide for this categorization? And the fifth one, or the fourth one, is related to the exploratory analysis you use in the Appendix A. So when you do the phonological awareness reliability measures, I think that you find very low reliability in some of the tasks of the phonological awareness composite. So you finally decide to use all the subcomponents to construct this latent variable, this construct of phonological awareness. But there are concretely two tasks that show very low reliability. And then on study 2, in the table 4.2, one can see that these are the tasks that are leading to very low measures. So the ones showing floor effects, and these are particularly phoneme segmentation. This one is particularly difficult for children, and pseudo-word rhyming. So why in the end did you choose to enter these two tasks that were showing so poor reliability and showing floor effects into the whole composite? And why did you choose to do this exploratory analysis that seemed to be data-driven? So I sometimes get lost in the analysis because there is no theoretical rationale about why you enter the factors this way. So it seems you've got two options normally to do this type of analysis. You enter all the tasks you've had, and the system tells you in a free way what are the best factors in taking into account the correlation among the tasks without any top-down driven theoretical view, or you enter the factors you think based on a theoretical account. And this is what I mean, what I miss. What is the theoretical account of entering four factors first, and 5 afterwards, and 8 afterwards, and 12 afterwards? So wouldn't it have been better to think of, for instance, I choose a task-based factor analysis, exploratory analysis. So I enter 3 factors. So blending, segmenting, and matching, or based on the grain size. In that case, 4 factors: phoneme, syllable, onset, rhyme. Or you combine all of them and you enter 7. But you previously present a theoretical account of why you do so. And then you test this with the tasks that are leading to floor effects and without the tasks that are leading to flow effects. Probably you did this, and you finally choose the one that offered you a best fit. But in any case, a theoretical rationale about why you choose these combinations will be appropriate. So these are the 4 questions. And now one suggestion. Sometimes I miss tables, and miss tables about, for example, the characteristics of the children, a table with the age and the standard deviation of the data, the mean, the standard deviation, the IQ mean, the standard deviation in the different studies, or the characteristics of the words selected. Maybe it's not relevant for the general analysis, but it could be relevant for you, because if you analyze the properties of the words and the pseudo words you used experimentally, then this can give you an important information about where children commit errors and what are the words that entail specific difficulties for the children. That would be interesting, particularly for you. So these are my main issues. I don't know if I've been clear, or there's something that you did not understand, or...
I think I understood, but in any case, I'll ask, or I'll try to answer, and if it's not clear, we can still think about it. So, your first question referred to this reciprocal relation between reading and phonology, and in particular, how the home environment affects this relationship. So the role that socioeconomic status plays, both in explaining the CES reading relation and the CES phonology relation. So we have no other information about their home environment, which, although I think it would be, of course, super informative. We thought about sending a questionnaire to the parents together with their consenting form in the beginning of the study. Then that went into negotiations with the authorities of the school system, which allowed us to go into the schools, and they weren't very happy with us asking questions. For some of the variables, for example, we wanted to know how earning, and we actually had a questionnaire with their literacy activities at home. And the authorities of the school system said that they didn't want us to ask, and that they had some information that they could provide in their database, which was socioeconomic status, which was education of the mother, and age, and not much more. But they said, don't worry, we'll give you that. So we couldn't ask, but I think it's probably very relevant, and the results again and again show that it is very relevant. We kind of knew this, right? We know that the home environment affects your reading acquisition process. It's also true that the study was not targeted at understanding this nature-nurture gigantic problem, but it would have been super informative. We tried, we couldn't do it. Even afterwards, when we asked the authorities for the information that they said they would provide, they said, no, we're sorry, we can't give you that information. So for example, the age of the children, we could only find their birth date in the second part of the study, and then someone gave us some of the information of the birth date in the time 1. So yes, I think there's a lot of new studies that I would like to run, and that is one of them, like how the home literacy environment affects this. Especially, I would like to know how the home environment affects the development of phonological skills and phonological awareness, which is something that I think is quite novel in the study, and is these floor effects on the phonemic awareness scores. And there's floor effects, but of course there's children that do show phonemic awareness, and it should be explained by what they do at home or what they do at the schools, but we are including schools in the models, and the school is not explaining the phonological awareness. So for sure, there's something that I would like to look at, and I would have liked to look at, but we weren't allowed. In any case, still, if we hadn't asked, I don't know how many parents would have answered. You know that the response rate is generally really low, so let's leave it at that. Now, for the second question, the phonological awareness task that avoided verbal responses. So honestly, the main motivation was pragmatical. Like, we could have not measured that number of children if we had to do it one by one. So the only things that we could not avoid to test individually were rapid automatized naming, Actually, we recorded the rapid automatized naming responses, and we collaborated with a research group at the School of Engineering to see if we could automatize the responses for rapid automatized naming in order to have a full digital battery. That's something that we're still working on, but it's not there yet. So that was the main idea first. After we found the results, and I started looking into the literature to try to understand better our phonological awareness tasks, I found these some articles like the ones that I referred, which Cunningham and colleagues, that try to dissociate this verbal response from actual phonological manipulation, if you may, and found that these are two components, different components of the phonological awareness tasks. And I think it's really important to discuss how our constructs relate to our tasks. So our phonological awareness construct doesn't imply a verbal response. The construct, as I understand it, is isolating and manipulating. Of course, if you want to know whether a child or an adult has done it correctly, you need to have a response. So it generally implies verbal responses, but this is not what we define as phonological awareness. So actually, we sent these for publication, and one of the arguments was, well, but your phonological awareness tasks are kind of weird, and it is true, but I think it's more informative than a flaw. I think it's like, if we really want to test phonological awareness, the verbal response, we generally use it, but it's not what we are trying to test. And the fact that it's dissociated, I think, gives us a better idea of how phonological awareness works. So that's that's a different question. And also, I think this can also explain the association between phonological awareness and the role that verbal short-term memory plays in our models, because also our verbal short-term memory task is different. It doesn't need a verbal response, and in most studies it's measured as pseudo-word repetition, for example. And so our working, I call it verbal short-term memory task, also dissociates memory for items and memory for order, and it taps heavily on memory for order, but it doesn't tap on memory for items, because the items are on the screen, so children don't need to remember what the item is, they just need to remember the order or the sequence of the items. So on one hand, so the phonological awareness has a verbal short-term memory that is an item verbal short-term memory embedded in it, all phonological awareness tasks do, and the verbal short-term memory task doesn't have or relies less on item verbal short-term memory. So I think that explains the role that these two play and the difference between what we find in our studies, part of the difference of what we find in our studies and what we find in other studies. Does that respond to your question?
Yes, and I think that you should exploit this aspect of your data.
Sorry, come again?
You didn't hear me. Yes, yeah. Yes, that's a good response. And I said that I think you should exploit this aspect of your data and this whole explanation.
I'll go into that at the end, but
okay.
So your third question, the categorization approach. Yes, totally. So why do you decide on some threshold? Like, what's the criteria like, you could choose any threshold. I actually went into the literature. Of course, no one agrees on what threshold you should use. So first, to be practical, I think that my idea is to do a better analysis on this, like for a specific article on this, on showing how varying the threshold in a parametric way can change either your classification accuracy or the role that preliteracy skills play. There's a lot of questions there. Of course, exploratory, I did it because I had to choose some threshold. And I tried to explain in the thesis why I chose this one. So there were both theoretical and pragmatic reasons. On the pragmatic side, we needed that the poor readers group was large enough so that we could actually run a model and make it converge. So if the poor readers was too smaller than what we decided, we had some converging issues. On the other hand, as I showed you in the bimodal distribution of the reading scores, there's very, very few children actually around the threshold that we measured. So if you move the threshold to 1.5 or you move the threshold to 1, the number of children that change from one group to the other, it's very, very, very small. So the results don't change much. I still yet have to do it like systematically, But I can tell you from my exploratory analysis that it doesn't make a big difference because there is this natural bimodal distribution in the sample, which was what I was trying to show earlier, that although thresholds are arbitrary, it is very different to choose an arbitrary threshold in the middle of a normal distribution in which moving a bit to the left or a bit to the right has very large consequences in which group children fall, versus our case in which the sample was so small at those sites that changing it doesn't change much. Also, the 1.3 standard deviations that we showed left 16% of the sample, as you said, in the poor readers groups, which is equivalent to, in a normal distribution, choosing -1, which is also what I assume some people do in the literature. So I was trying also in a way to replicate that in this bimodal scores. Okay, your fourth question on the exploratory analysis in the appendix. To start with, there's a reason that's in the appendix, so it needs more work. I agree with that. I was surprised by the fact that I had never done like this kind of analysis before. Well, most of them, but this is the one that I had done less so. And I was surprised by the fact that even doing a data-driven approach in which the model had no information of what the factors should be, a lot of information on the item analysis, which was your next question actually, pop up in the results. If you look with detail, and I think you have the results of this exploratory factor analysis, you see, for example, that there's different factors corresponding to the number of syllables in the items. So for me, that was very reassuring in showing that the task is very sensitive to children's skills because it actually captures the variance and the inner manipulations of the items, which I didn't discuss at all in the thesis, but it's also, and that was my last point, it's also something that I would like to do next. So there's a lot of analysis. There's a lot of things to look into this data that I haven't yet. So I had to stop at some point. And one of them is, for example, how the characteristics of the words or of the items modulates the results. And so, for example, for all of the phonological awareness tasks, we have manipulated the number of syllables, the number of phonemes, the syllabic complexity. And at least from the exploratory factor analysis, I think the tasks are capturing this very well, except for those tasks that have low reliability, as you mentioned. So rhyming, and this is another critical issue that I think is theoretically very important, is that rhyming is useless. I mean, children cannot do it. And I have, of course, this was our first time working with this, and I was trying to understand this, and I was looking at the literature, and I didn't find anything in the literature, but I found like an unpublished doctoral thesis from a longitudinal study run in Chile that had the same results. Then I talked to some people informally, and they said, yeah, for us, rhyming. I talked to a PhD student from the BCBL last week, and he was like, I ran a rhyming task, and it doesn't show anything. And I was like, me too. So we are not reporting this because we know that it's hard to report null results, but it seems like in Spanish, rhyming is not like in English. Like children don't either. They don't have the concept of rhyming. I don't know whether it's like they don't have the concept, they can't do it, we don't practice it enough in kindergarten, but it doesn't work. And it seems that it's a matter of the language and not of the task itself. And then on deciding which one to include, so I went backwards and forwards many times. And what we used to decide which ones to use, or what I tried, and maybe it was not clear enough in the thesis, was to have the most informative one. That's why I did item response theory and latent ability scores, because we were measuring phonological awareness in a way that is different to what is usually done, and we're claiming that something that is different to what we really generally think, that is phonological awareness does not contribute unique additional variance than above and beyond letter knowledge and rapid automatized naming. And so, So I tried to compute a measure of phonological awareness that could be the most likely to find an effect. And even though I did that, I couldn't find it. The other issue is that I could have used all of the phonological awareness in the model tasks, let's say 4 tasks in the model, but they are of course highly correlated, and that is problematic for modeling. So I had to either average them, or what I did was kind of a weighted average of their response to intervention. And also with the response to intervention, no, item response theory, it's the same acronym. Also with item response theory, we could, to the best of our knowledge, overcome the floor effects, since we computed latent ability scores, and that changes the scale, to try to give phonological awareness a chance, and we still didn't find anything. With respect to your suggestions, yes, totally, I agree. I think kind of that is a flaw from, so the second study is the one that I wrote first, and I included the demographic table in the second study, but I should also include it in the other ones, even though the sample is sort of the same, but it's not the same exactly in the other one. So I should definitely include that. And with response to the word and item analysis, as I said before, I think there's a lot of information there that we need to look at, but we haven't found the time yet.
So thank you very much for your responses. I think that you were very clear. So thank you. I think it's enough for me. It's Nadine's turn.
Great, thank you very much. Yes, I agree that you did a fantastic job, and I was very impressed. And I know how much work it is to run these longitudinal studies. So I could see the amount of dedication and hard work that you put in it. I have also a couple of comments, and I think I like the approach of just outlining them all first, and then let you respond to them, in one coherent response. So one of the main questions I have was related to oral language. At least in English, there has been a lot of studies showing the value of including oral language measures in predicting reading outcome. And what I'm talking about is vocabulary measures, but also oral listening comprehension. Right, and it comes down to the fact what kind of outcome measures you choose. And I give you an example. So if you choose reading comprehension as an outcome measure, vocabulary as well as or listening comprehension are of huge importance, right? Because again, you may be able to decode the word, but you may not, you have no idea what the word means that you just decoded. So there's this, if you're familiar with the reading rope, right? So I was missing the upper part of the reading rope in the thesis a bit. Like the discussion, at least, should we look at this? And if not, why shouldn't we look at it? Why maybe some of the results you found could be related or could be embedded in the lack of oral language measures. And I think it would have been really interesting to see, if you compare it to English, which you did a lot in the presentation, how do these oral language measures, what is the role of oral language measures in an orthographic language or in Spanish. That also brings me to these outcome measures that were raised before. So not only how you define who's a poor reader and who's not, but also what measures were used to define those, right? Is it single? Is it a single word reading? Is it speeded single word reading? Is it just decoding without speed? Is it non-word reading? Is it what is the role of sight words in the task you used as an outcome measure? I think this is also, I saw a little bit of a discussion on this, but I think it would be really important to clearly define why you used the outcome measures and why you didn't choose other outcome measures, and what kind of results you would have gotten, if you would have chosen other outcome measures than the ones you chose. The third part I have here is related to the introduction and the presentation of today's excellent presentation. So that so it's read a little bit like no one has ever looked at this in Spanish, but at least to my knowledge, there's 5 commercially available huge screener systems in the US that actually screen Spanish-speaking kids in Spanish, reading in Spanish. So there's the Spanish Dibbles, there's the NWEA, there's the Pulse, there's the Star, there's iStation. So these are all like systems that that are currently used in the school system for Spanish speakers to assess how well their Spanish speaking is and to predict their Spanish reading outcomes. And so I was a little puzzled why this kind of work was not included or discussed, or at least mentioned that there are these screeners. And so it may not be easy to find using like a Google Scholar approach or some other literature approach, because it's probably all embedded in the manuals of the commercial available screeners, but they're widely used and often used, especially for children who are immigrants and who come to see, should they be screened in English, should they be screened in Spanish, and what is their reading outcome in English and what is their reading outcome in Spanish. And some of them are, not bilingual because they just, arrived in an English-speaking environment. Another interesting part that I thought would be good to explore is what are the implication for education that coming out of your thesis. And so especially when it comes to rapid automatized naming. So I'm always really puzzled about the rapid automatized naming because it's really nicely predicts, especially reading fluency, right? Which brings us back to the outcome measures, but it cannot be remediated, right? So there's currently, and even, I'm a good friend of Marianne Wolf, even she says, there's nothing we could do. So I'm always wondering, if you can't do anything about it, should we still include it in the screener? Or, if you think about timing, like we want to screen as many kids as fast as possible, so I think a discussion of like, how would that look like in an education system would be really helpful. 2 more, and then I promise I'm done. And one other thing was related to socioeconomic status. So you had mentioned that it's primarily middle and high income kids that that were a part of the study. And I was just wondering, even though you found SES being part of, or being important for predicting your outcome measures, or as part of your model, why is that the case, even though you had like a relatively narrow SES? And if that is maybe related to oral language, and what are you actually measuring SES? Or especially if it's defined with mother's education, was that like a somewhat implicit measure of oral language that you may have had in there, or less like not home literacy, but maybe home language? And the last part was related to your, brain measures, which I thought was really great that you included those. But I realized that you only have 7 poor readers, I think, in the analysis. And I think, it would be really good if you could, just discuss, the limitations of comparing 7 versus 28, and maybe, looking at effect sizes and looking at like, is that, a preliminary result, which, I think is really interesting, or is that something that is, that should be used given the small sample size, to make, meaningful decisions. Yeah, so this is, my couple of points. And let me know if anything of this was unclear.
Okay, thanks. I think I wrote it down, but I might need some help if I forget something. Thanks for all the questions. So the first one, referring to oral language measures. Of course, if we think of the simple view of reading or the reading rope, we know that most of the tasks and measures that are used are strong predictors of decoding rather than reading comprehension or fluency, which is not as much discussed, although in Spanish, I think fluency is really important and we are not paying that much attention. And this will relate to your run question, but disorganized, sorry. So I did measure vocabulary, and we don't see a very strong role for vocabulary, but of course you shouldn't see a strong role for vocabulary, or you wouldn't expect for the coding. I didn't run, in the second study, I could have run, and I didn't run a model for reading comprehension. And maybe if I did run a model for reading comprehension, we would see a strong effect for vocabulary and a reduced effect of other preliteracy skills that are more dependent or associated with decoding or basic coding skills. So with respect to oral listening comprehension, so originally when we tested reading comprehension, we had the ProLec battery, which has two subsets. So some that increase in semantic complexity and some items that increase in syntactic complexity. So in our pilot study, we found that those the subtask that increase in syntactic complexity didn't work very well for children at the end of first grade. They couldn't complete it. So we decided to turn that into an oral comprehension task. So in part of the sample, the research assistant would read out the sentence and ask the child to answer. So that would be an oral listening comprehension task. It's not a lot of items, but that's something that I would like to look at. It's limited, it's not a lot of items, but since the sample is so large, I could select those children that did that and see whether I can replicate those results of what we know about the simple view of reading. But our main aim was to focus on the coding. Actually, when we started the longitudinal study, we thought we would end by the end of first grade. So by the end of first grade, it didn't make any sense to think of trying to predict reading comprehension, because they don't have a lot of reading comprehension by the end of first grade. Then the opportunity came up to follow 1 year more. And you probably have seen from the whole thesis that the second grade results are kind of in and out. I mean, the whole study is not designed in trying to predict the second grade results, but the first grade results. Also because the sample size is smaller in second grade because of the children that don't continue in the study. So I think in the future, I would like to look at this data from that perspective. So we could think of trying to predict second grade, working with a sample of 250 children, looking at the listening comprehensions in those that we have that measure, and trying to look at that and how that is modulated by orthographic consistency, for sure. And I should probably discuss some of this, include some of this in the discussion, which I haven't. So thanks. Your second question referred to what we used to measuring to categorizing. So what we used was the composite score. So just like a regular average between the coding, fluency, and comprehension. Of course, we could have done many different things. The rationale for this was first that they are highly correlated. So we thought that the composite score reflected pretty well their abilities in these three skills. Of course, if you cannot decode well enough, you cannot comprehend. And you need some studies show that you need to achieve like high accuracy scores in decoding to be able to start gaining fluency. So these are really correlated among each other. And also because the rationale was that we wanted to predict overall reading skills. So if you are a good decoder, but you have comprehension issues, I still want to detect you early on. So there was no emphasis on any one of them, unlike the second study in which we ran separate models, because the rationale was, let's try to predict any child that is going to have any kind of reading difficulties. And then by looking at their profiles, we could have a better idea of what kind of reading difficulties they would have and whether we can do something about it. So that's the idea, but also I think it'd be interesting to include that in the discussion on what we would expect or how our results would have been different if we used different categorizations, measures for categorization. So, and also you refer something to side words. So for our decoding tasks, were a list of words and pseudo words, and they were not very frequent. So I used the average of words and pseudo words, which were also very highly correlated because there were not very many frequent words in the coding task that you would expect for as sight words. And your third point referred to introduction and not including all of the commercially available screeners that they are. And that's for sure a bias on my research background and on the fact that I looked into Google Scholar and they are not there. But you may have noticed that I included a database search. I can't remember now the name of the site, but you probably know it. And I couldn't find anyone with the characteristics that I mentioned. So I couldn't find anyone that would be digital and administered in groups. So I think in that sense, this is the only one that I know, and I know that you have developed one recently that can achieve this. And I think this is critical, especially in undeveloped or countries on way of developing like Uruguay, because you cannot afford to screen children individually in the school setting. There's no way. That's not. I don't even know whether this is going to happen with a tablet-based game, given children already have the tablets in the schools. We have not yet been able to convince anyone that they should use it. But so that's why they are not included. Also, after I know the DeBells, and I found some, to be honest, I found some recently. Also, I think that's a result of the fact that these are Spanish assessments in Spanish, but that are carried out in the States. So I don't know of any other assessment that is run in Spanish-speaking countries, so in Spain or Latin America. So I think that's really important. And also in these commercially available studies, from the ones that I've seen, they are generally, maybe I'm wrong in this, but they are generally based on what we know from the literature in English. They have not run longitudinal study to see what are the main predictors or what we should be testing. They're like, okay, so in English we test this, we're gonna test the same in Spanish. And I think one of the points of the thesis is showing that maybe this we need to think this thoroughly about how we're gonna translate a screener from one language to another, because maybe we don't need to measure exactly the same. Regarding your implications for education in the screeners. So one of the issues that you were bringing up is, for example, the fact that we don't know what to do about children that perform poorly on the run tasks. But I think it's still very informative. For example, imagine that you screen a child and you find, you predict that they're going to have future reading difficulties, but you see that they have strong phonological awareness and letter knowledge skills, but they have low rapid automatized naming. Okay, maybe you don't know what to do, but you know what not to do. You know that no matter how much phonological awareness training you do on that child, that's not going to help them overcome their issues. This also brings me to this other point that I think it's okay, maybe I didn't look for this directly in the literature, so I don't know how it's treated, but I don't see it popping up as often. And I think it's a reflection again of the fact that most of the literature is carried out in English, is that I don't see fluency being discussed as much. And we know that in Spanish, the coding accuracy is generally not the main thing. So I also work with, I have a master's student that is a clinical, I don't know the name in English. Anyway, she works with children trying to overcome their learning difficulties. And we're always discussing, like, I don't know how to help them out because they are okay with the coding, they're just slow. So that's what's most common. And we don't really know how to work on fluency. So also the run task should be a strong index of their fluency skills because of some of the cognitive skills that it involves. And I think it's really important, especially in Spanish, to test for fluency issues and to think what we're going to do to test, to intervene about fluency, which is the most common difficulty encountered in Spanish. So I would still include it in my screener. Although, as I said before, it has the big challenge of being hard to automatize. But it's hard, but I mean, Google works great. I mean, Google can recognize any voice. We really can't recognize 4 names of colors or letters or images that we already know what they are. I mean, it's a pattern matching problem. It's not a speech recognition problem. So I'm pretty confident that we're gonna solve that not too long. away. Now, with respect to socioeconomic status, how the schools are categorized by the school system as being in the as high SES. So the school system categorized into 5 quintiles. So 1, 2, 3, 4, and 5. So 5 groups according to the socioeconomic status. But this is for the schools, which includes also the socioeconomic status of the families, but other things related to the school itself, like infrastructure, teachers, etc. So first, the fact this was quintile 4, above quintile 4 and quintile 5. But this is a public school system. So this is not the richest kids. The richest kids are not there. They're going to the private schools. So this is middle high SES for children attending public schools, which is probably, I don't know, but in the general population, more related to middle SES. Then inside school, there's a lot of variability. And so within each SES in the schools, we have children, what we call SES, children SES in our study is maternal education. And from there, we have children whose mothers have not finished elementary school, children whose mothers have not finished secondary schools, and children whose mothers have completed university degrees. So we have really large variability in our SES measure at the individual level. So I think that's why we see this SES effect, because it's not as restricted as you think from the schools, because within schools there's a lot of variability. I have a note, something about implicit, but I don't know what it means in your question. Anyways. And for the last question on the EEG study, I definitely think this is an exploratory study. The sample size is very small. First, I have a bias towards this study because I come from a background in neuroscience and I love it and I want to keep doing it. And the behavioral study took so much of my time in running it and in the analysis that I couldn't devote more time to study for, but it's the ones that is closest to my heart. So I hope I can keep working on that. On the other hand, I think it's very valuable evidence, however exploratory and preliminary, because the sample is so small, because there are hardly any studies in which we can follow children longitudinally. There are hardly any studies that measure auditory processing in pre-readers. So you have quite a few studies in newborns and in the first few months of life. Then you have a lot of studies with school-aged children, but there are hardly any studies with pre-readers, especially in testing this temporal sampling framework of the relation between temporal processing at the brain level and their future reading skills. So I think it's still really important, although we should take it as it is with a reduced sample, for what we understand about how these brain rhythms and reading acquisition work. This is one of the studies that I would like to run again. I think it's feasible now that we have Lexiland to screen children and try to select a sample of children that we think are going to develop reading difficulties. Because of the problem of this longitudinal study with EEG with a small sample is that you need to make sure that in 1 year later, you'll have enough children that will have reading difficulties, but the likelihood of finding that is what, 10%. So if you do it randomly, you won't end up with this kind of sample that you need. So you need to screen children first and then select them to go into the EEG study. But we can easily screen them now. So that's something that I would like to do again. Also, we had some technical issues in which there were delays in the system in which we could not test the face locking itself, and that's why I used powered instead of using face locking or coherence. And so there's both types of analysis and operationalizations with respect to the rhythmic sensitivity measure. But that's something that I would really like to look into in the future. And I think it's quite feasible. Okay. That answer your question?
Yeah, great. Thank you so much. No, I really enjoyed listening to your responses, and you explained a lot, and you presented it with great confidence. And I've been feeling that I'm listening to a established colleague, which is really great to hear. Thank you.
Thank you.
Okay, so I think it's my turn. So I would like to congratulate you, Camila. That was a really excellent work, fantastic presentation. So I had 4 questions, but they have asked you already 3. But I'm going to talk a little about the 3rd one, because I mean, this is the one from Professor Gaab at the end that you were answering. So given that it entails some, I mean, if you want to do it again with a bigger sample, so how was the, so have you computed the base factor? I mean, I know there is the N7 versus N28 or something. So have you computed the base factor? Because I mean, my guess is that if the base factor is in favor of the alternative, like 1.2, it would, what I would say is, okay, I will do something else, or I will change things. Because I mean, that would be nice to do. I think it was, if you compute the p-value, I think it was significant. Was it? But if you compute the base factor, I would like to know whether, I mean, if it is 2.5, then with a bigger sample can go beyond 3, would be like, okay, we would believe it and everything. So I would try to do that, because I mean, p-values, I mean, we know that they have their own issues. I mean, I'm not saying that base factors are perfect, but I mean, yeah. And then because I have this question, the oral comprehension question, and then the boundary, the threshold for readers, and then the only one question that I'm going to really ask was that although the literature, I mean, I'm familiar with the topics, of course, but I'm also familiar with topics of dyslexia, and then there are all these groups that they claim that it has to do with visual cognition and so on. You were using a visual memory task, which is a compound because it has some order processing, phonological component. So why, I mean, I understand that you are using a lot, you have like a number of variables, and you have to restrict yourself, because I mean, you don't want the kids to get tired. But why not using any visual cognition measure, in particular at the beginning of reading? I mean, in our case, we are getting some effects out of that with pre-readers. So, I mean, why not? Why? So why then you use it? Just out of curiosity? Because I mean, the work is excellent anyways.
Yeah. Okay, thank you. Yeah, by being the last, you only get a few questions. So for the base factor, I know I haven't computed it. The amount of statistics that I learned in these 5 years is like spectacular for me. I didn't get into Bayesian statistics, but that's definitely something that I will do, because I think we're all going there. And because of what we were also describing of many things in the thesis, there are null results, and we're going to need support for that. So for sure, I need to do that, and it's a good idea to do it before I run again this study to see how much weight our evidence has in order to follow up, or whether we should change something or something like that. Mm. So yeah, for sure. With respect to the visual stuff, so what do you refer by visual cognition? You were saying that you find things in readers. What kind of task do you use?
Really, I mean, simple tasks that, like the one that some groups, for instance, in Italy, there are those groups that they claim that basically the deficit in dyslexia, I mean, I'm sure that other people, they don't agree anyways, it's due to visual processing rather than phonological processing. And I mean, there is some truth there, that I'm sure. But in your case, you focus on phonological awareness, which actually you didn't get. There's the rhyming. By the way, as for the rhyming, it will be interesting to do that. I mean, at BCBL, that's kind of easy because they have the French really close. So French is going to be kind of deep language. In Uruguay, you have the Brazilians. We are not that far away. And Portuguese is kind of, at least for Spanish-speaking people, it's hard to understand, at least the one from European Portugal. I don't know if in European Portuguese in Brazil may be easier, but anyways, it's clearly more complicated than Spanish, more phonemes, more, I mean, at least for me, that I only can say a few words. But yeah, I mean, I'm talking about purely visual tasks with no phonological component, or tasks that entail some multi-sensory integration, which I mean, after all, I mean, reading is integrating sounds and visual signs. And actually, I mean, a number of people, they claim that it's related to some of the deficits while learning to read. But in your case, I mean, you focused, I mean, as you said, letter knowledge and phonological awareness. In Spanish, is like, okay, I mean, if I know the letters, I have the sounds. So can you say, so I mean, you could have used some of those, maybe?
I have actually. So, as you know, Marie Lallier, maybe no, you don't know. Marie Lallier from the BCL was also really involved in the studies. And as you know, Marie has been working a lot of the visual attentional span theory. And so we implemented in the Lexiland battery 2 visual tasks. One was visual stream segregation, in which you have to decide whether the continuous sequence of flashing balls were like 2 balls or 1 ball. So you have to decide whether a sequence belongs to 2 different things or 1 thing. It's hard to explain, sorry, but maybe you know the task. So we used visual stream segregation, and we also employed a task that was visual entrainment. So since we were interested in this whole idea of how brain rhythms relate to future reading acquisition, and it's not only through phonology, there's also the visual attentional theory that is also rhythmic. We also tested visual entrainment, in which we had a primer that would flash at a given rate, and then we will have a target that would be in phase or out of phase with the primer. So I didn't have time to analyze this and to include it in the thesis, because it also opened a whole other window of dyslexia theories related to visual attention, which, by the way, I think I agree that they are probably relevant. Well, I mean, they are relevant. And I think, of course, dyslexia, in reading, there's so much processes involved, so many processes involved, some of the kids, and there are some studies showing this, I think most of the kids will show phonological problems, and that's why they can't read. And some kids can't read because of other reasons, and some of these probably is because of their visual attentional skills. Mm-hmm. So we included these 2 tests in the Lexiland battery. I did some exploratory analysis. We could replicate some of the results in the literature with respect to the descriptive, like how children perform, which we were very skeptical. I mean, these are cheap tablets. This is, as I showed you in the picture, like 4 children playing at the same time in a hallway. I mean, it's really hard we thought it might be hard to capture their attention. These are tasks that are really fast, so you have to be really focused into it. But we could replicate some of the results in the literature, so I think there's important information there. But I didn't have time to put it together with the other tasks, because one of the things that I think would be interested, for example, is to use, and we were wondering about this, is if we add this other task into the screener, can we improve our classification accuracy? Can we capture children that will have reading difficulties, but not because of the phonological deficits, because of other reasons? So that would be more comprehensive in a way. So we have, but I don't know, because I haven't looked at it yet. But
okay, yeah, because, mm-hmm. So maybe there will be an increase, but it could be really small. But I mean, that's an empirical question.
Yes, and even if it's small, I mean, there's the theoretical thing and there's the children's lives. I mean, even if it's small and you only find 1 out of 150 children that have that issue, you still want to find them. Yeah. So I think that it will be important, and I'm going to try to, that's one of the things that I need to work on next. And actually, I'm going to meet Marie soon, and we're going to start working on an article on those results. But we still have, we're going to start looking at the results and see what's there first. And yeah, what you were saying with respect to rhyming and Portuguese.
Yeah, as for the rhyming null effects, what I would say would be nice that maybe some other people, they have done it anyways with bilinguals. So that's why I was saying that some areas in Brazil, in the south, they are close to Uruguay. I'm sure they speak Spanish. And
in Uruguay, every Uruguayan thinks, every Uruguayan thinks that they can speak Portuguese. So unlike Portugal, we think we're all like super Spanish, Portuguese bilinguals. So yeah, we could definitely run that to compare how it behaves.
Because maybe in Spanish, the same people, the same kids, in Spanish, they will not show the effect, but in Portuguese, yes, or maybe all Uruguayans who know a bit of Brazilian, they may get the effect, but Argentinians may not, because I mean, they are a bit farther away from Brazil, even though they are from the same geographical area. Yeah, I don't know.
So,
I mean,
yeah, in the border, generally children are bilingual. So you could run that with children living in the border between Uruguay and Brazil and see how they perform in the two languages. That's really interesting.
It may be also, it'd be interesting to think about how you present the task. So when we do rhyming here in English and we ask them, which 2 out of 3 rhyme, usually you get blank stares because they don't know what rhyming is. But if you say which 2 out of 3 sound alike, and you give them like red, cat, house, and you just ask them which sound alike, that is a much easier task than like the concept of like rhyming. And so we found that actually works really well.
That's interesting. Yeah, I think if we're gonna go into looking at rhyming in depth, we should probably manipulate instructions. Now, as with all of the other tasks in the Lexicon Screener, there were example trials and test trials with feedback. So children could listen to 2 words that rhyme and say, yes, they do, and 2 words that don't rhyme and say they don't. Of course, that's different to hearing 3 words and saying which one sounds alike. That's easier in a way, no? Because you have you always have a yes response in the test set, and that's easier to answer than is this yes or is this no. But as I was saying before, there's a lot of people not finding children being able to rhyme in Spanish. And I wonder how that, with respect to what you were saying of the screeners in the States for Spanish speakers, how does that work? It'd be interesting to look at the results of the screeners that include rhyming for Spanish and see whether that's actually measuring something, or it's just there because in English it works.
Maybe in English, I mean, the examples that you gave were monosyllabic words, which in Spanish, I mean, typically there would be, so head would be red. I mean, you could have like multisyllabic words for rhyming and everything for the kids as well.
We had
multisyllabic actually. So, I mean, because in Spanish, in English, there are lots of monosyllabic words. In English, it's very different. The way we have the accents, I mean, there are a few, I mean, they are difficult to compare a bit. That's my guess. So probably the items are quite different in Spanish and in English. So that's another difference.
Sí.
Yeah. So, Camila, so are you done, or I think that you answered correctly? Yeah.
I think I answered everything. Do you have any other questions?
Yeah. I think that. No. So then what, I mean, Professor Acha, no, so now we're going to deliberate a bit and do our paperwork that it may take a few minutes because it's online and things online take longer than expected. And then we will get back, no, Joana?
That's it. We have to get out from this room, go to the deliberate room. Yeah,
I can make a breakout room.
Come back because we now have to sign documents.
Yeah, I mean, we have another link that we can go, and then at some point we will be back. I don't know exactly how long it's gonna take because it's paperwork, and nobody knows. I mean, it takes longer than expected always.
I will say it might be like 10 minutes, not more. And we don't even have to get out. I'm thinking that we can silence our micros and just go to the deliberating room without getting out from this. Yes.
And stop the video.
And stop the video as well.
Yeah. Okay.
So see you in a few minutes.
Okay.
Thank you very much, Camila.
Thank you.
Camila. Okay, Camila. So once the committee has talked and after the deliberation, we have decided to give you the best score, which is sobresaliente. So congratulations for the results. A very good presentation and a very good work. you know that for the cum laude and extraordinary award, we have to vote individually, and people from administration will tell you about it. We cannot say anything right now.
Exciting.
So this will come later.
Can I say something? This
Yes,
is Juan.
of course, of course.
We were talking with Manolo that we didn't have the chance to say a few words.
That's true.
And not that Camila needed any defense or anything like that, as you know, but I wanted to say how thrilled I am that this thesis defense has occurred. And this is a very special day. You have to know, we are on strike in the university. I had to ask to the president of the union to hold this without any problems. And this is maybe part of what this work was, like an enormous effort to reach the high levels of scientific achievement that we expected from Camila, and that she delivered. I mean, we are really, really happy. And although sometimes I had the opportunity or the drive to say something about what you were asking, I had been already scolded by her in previous talks. And so I kept silent. So I won't tell anything, say anything about the science. I'm really happy. Thank you all for coming here. Thank you for this panel. And congratulations, Camila. It was a really great pleasure working with you.
Thank you, Juan. Me too. I really enjoyed. Is it my turn now? Can I say something?
Yes, I can.
So,
yeah, you can.
Yeah, I really enjoyed going through the process of this thesis. I really like the thesis. I like the studies. I like what we found and what brings us next. And it was a pleasure to work both with Juan and Manolo and everyone at the School of Psychology and at the BCBL in this weird hybrid in which I was traveling part of the time living in Spain and part of the time living in Uruguay. And I'm thrilled to have gone through that. So I'm really happy about it. Thanks.
I would
So
say
Manolo,
that,
you want to say something?
yes,
Yeah.
yes. Thank you, Manolo. Thank you for allowing me now. Yeah. Now, Noel, what I wanted to say is that I am very proud of you. I think you are like a superwoman. So you even during the thesis became a mother. So I think the hard work that you do is amazing. But not only being a hard worker, it's also that you are, you know, you need to you look for the tools when you need a specific tool, either a theoretical tool or a methodological tool. So I'm sure you will become in the next coming years one leading figure in the cognitive neuroscience field. So yeah, thank you for all your effort, for doing all these marvelous theses, of course with you know, many difficulties, but you still have a lot of data to analyze and bring some new theoretical insights. When you told me that you had only 4 months or 5 months to finish the thesis, I said, well, she's not going to meet the deadline. I mean, it's impossible. But then, you know, I mean, she was working unbelievable fast, doing analysis and writing. And so, yeah, the future is yours, Camila.
Okay, now. So thank you very much to the directors for the speech and for the words. So Camila, I have sent you a document. So before you go to celebrate, please sign the document I have just sent to you, okay? And send it back to me. And afterwards, you have finished. So thank you very much for all of you being here.
Thanks for being part of the committee.
Thank you.